So we have started classification of rapier. So we have seen what is single rapier concept in detail. This concept we have covered. Its advantage, disadvantage we have covered. So this is what is single rapier. The rapier going from only from one side and taking weft on the other side, and the weft is coming on the what, on the receiving side. So this is what single rapier we have seen. Then we have seen double rapier. So again double rapier is what, rigid and flexible we have seen, and its advantage disadvantages we have seen. So this what, flexible tape is there, winding of flexible tape, unwinding of flexible tape. If unwinding is there, the tape goes inside and comes out. Double sided means two rapiers, giver and taker rapier is there, and the weft is exchanged at the center. Then rigid rapier is there. Instead of flexible tape we are having what, rigid rod going from both the sides. This is again giver rod and taker rapier, giver rapier. So this we have seen in the last lecture. Double rapier, double rapier, that is again the concept we will see. Classification of double rapier: devas, that is tip to tip transfer, and gabler, that is loop transfer. In the next coming slides we will see this classification. So overall now we have discussed the main classification: single rapier, double rapier, and always the single rapier is rigid rapier, and in the double rapier we have discussed the concept flexible rapier and rigid rapier. So here we can see ribbon or rapier enters from both the sides. It may be rigid or flexible. Duration of duel reduced, more speed is possible. So if you see in the single sided rapier, the rapier is going from one side to other side empty, and it takes the weft on the other side and the weft is inserted. So more moment is wasted. But here in the double rapier, again less moment is wasted as compared to what, single rapier. So moment is wasted means what will happen, the speed of machine increases. So type of rapier, that is rigid rapier or flexible rapier. So rigid rapier is here how it is. It is thin wall tube, approximate 10 to 50 mm diameter is there. So two tubes are there, one coming from left hand side of loom, other coming from right hand side of the loom, and exchanging weft at the center. So giver takes the weft from left hand side, it comes up to the what, center, and from the center the taker exchange the weft. So these are what, rigid rods of 10 to 15 mm diameter, or a hollow bar of rectangular cross section, or a hollow bar. So round bar or a hollow bar. So in our workshop on the Dornier machine we are having carbon fiber rigid rapier, that is of hollow bar. So we can use hollow bar or round bar. So what is the advantage? They do not require guiding across the warp sheet. Means what's here, as the bar is rigid, there is no any external support is required in the shade to hold the rapiers. So rapier itself is self-sustainable to travel across the shade, that is what, rigid rapier. So it does not require any guiding across the warp sheet like projectile require guides across the sleigh. So here we do not require any guiding element in the fabric width. The rapier head slides on the warp or on the race board. So we know rapier and rapier head. So rapier head is called as what, giver or taker. So it does not require any support and it slides on the warp or on the race board. High mass and rigid construction ensures straight movement of rapier heads. So already the mass is high, and drive for the rapier, left hand rapier is from left hand side, and drive from right hand is from the what, right hand side. So drive is already a rigid construction, so there is straight movement of the rapier rod inside and outside. So there is no any external Support again here required. A great diversity for both warp and web thread in yarn count and character. So a great diversity means what more versatility we can go for warp and web threads in warp count and character. So more EPI, PPI also we can go in the rigid rapiers. So hollow bars of rectangular cross section are attached to the rapier heads. If round bar is not there, we can have hollow bar. So our Dornier machine is having what hollow bar carbon composite near about cost of what 40,000 one single rapier. So two rapiers it is what 80,000. So this is what rigid rapier. So disadvantages here, their large floor space required at least twice the fabric width. So here for the rigid rapier, not for the flexible rapier, we are discussing about rigid rapier. Here we require double space of the width of the fabric. So width of the fabric is 60 inch. The space required for the loom is 120 inch. House here 60 inch means what? 60 inch fabric width. So left hand rapier will be 30 inch, right hand rapier will be 30 inch. So this 30 inch from the left hand it will go inside and again up to the center of the fabric or center of the machine. Again this 30 inch goes outside of the machine from the left hand selvage. So that much again 30 inch outside area is required here. So more area on left hand and right hand. Double the width of the fabric. So main disadvantage is what here? Larger floor space is required at least twice the fabric width. Half of their moment is wasted. So this is common to all double rapiers, not for a single rapier. Single rapier again more amount of moment is wasted than the rigid rapier. So see here how the giver takes the weft and it comes to the center and it gives weft to the taker. So giver while going it is going empty. So this moment is wasted. Same again taker while coming to the center it comes empty and while going it takes what? Weft. So while coming the moment is wasted. So half of their moment is wasted. They are coming what? Empty. So this is what a disadvantage of the double sided rapiers. So this is what rigid rod and rapier head. So these are what giver rapier head. This is what taker rapier head. So this is what gripper, giver, left hand gripper, right hand gripper. So these all the concept gripper and rapier head is same. So this is what rigid gripper, left hand and right hand. So here we can see here the gripper is there, right hand rapier is there, right hand rapier head is there. So this one is there and here the rod is there, rectangular rod. So drive is from the bottom. So here this is what right hand drive. So here gear is there, gear meshing with the what underside of this rod. So when the gear moves forward the rod goes inside the shade and when gear moves clockwise the rod comes out of the shade. So this is what right hand side of the rapier. So here we can see this is what rod and gear. So here the gripper is attached, this gripper is attached. So this gear drive is present on both left hand and right hand. So this is what 30-inch rod will go outside. So more space will be required for the what rigid rapier. So next we have completed what rigid rapier, how the cross section is there, how the disadvantages are there, what are the advantages. Here extra guiding is not required throughout the width of the fabric in the rigid rapier. Now we'll see what flexible rapier. So here we are using tapes of rectangular cross section, though here we are using flexible tapes. So 25 mm width is there, 10 mm thickness is there. So 25 by 10 mm tapes are there, made of spring steel or plastic. In earlier cases, conventional rapier loom steel was there, spring steel, but more disadvantage of the steel was there. Cutting of the steel, bending of the steel, and cutting of the warp ends, warp breakages. So spring steel has been replaced by the plastic. So flexible plastic winding and unwinding of the tape can be done here. So this tape size is 25 by 10 mm. So 25 is width and 10 mm is. So they require guiding across the shed, especially for large working widths. Suppose 60-inch width is there or 120-inch double width. So a rapier requires guiding across the width of the fabric. So rigid rapier does not requires any guiding, like how the projectile having the guides on the sleeve. And mostly the rigid rapier is suitable for small width, not for the wider width. And flexible rapier is suitable for wider width. So maximum width for the rigid rapier we can go 60-inch. More than 60-inch if you have to go, you have to go for flexible rapier. So 120-inch width, 90-inch width. So as the width increases here, for the tape we require guiding elements, guiding teeth across the width of the fabric, and these guiding teeth are fixed to the what sleeve. So guiding teeth will be on the what sleeve of the machine. So these are what the ribbed guide is similar to that used with the gripper projectile viewing machine. So how the guides we are using in the projectile, same guides are fixed on the sleeve, and in these guides the your flexible tape is moving forward and backward. So this is what guiding. So more width of the fabric, more guiding. If the guiding is not there, so exactly in the straight line your rapier will not go. Either it will hit to the sleeve or it will hit to the what fell of the cloth, and breakages of warps may take place. So this is there. Then here next, directing the flexible rapier band through a fixed housing on the loom frame just outside the reed. So outside the reed, we are having outside the reed or outside the machine where the rapier is going out. So the control for the rapier is by the what rapier drive, which is sitting in the housing, fixed housing outside. So we are having left hand housing and right hand housing. So in the figure I will be showing you what is the housing. So here we can see this is what flywheel is moving. The band is fixed at the one end, and here at the next end we are having rapier. So rapier is moving forward and backward as the wheel is moving clockwise and anti-clockwise. And this is what driving gear, right hand driving gear. So we are having here left hand driving gear also, right hand driving gear and left hand driving gear is there. So we can see here the tape is going inside on the what sleeve. So here this is what right hand rapier, and on the sleeve we are having the guides. Okay, in the guide, in these guides the rapier tape is moving forward and backward. So this is right hand, left hand also like this wheel will be there. The drive is from the main shaft, driving gear. This is what sleigh drive here. So here we can see this is what your rapier tape. Okay, and these are what the guides on the sleigh. So we can see here sleigh, and here the guides are there 1 2 3 4. So this is what giver rapier, and this is what taker, giver taker. So giver tape will be there, rapier will be there, and taker will be there. So this rapier tape is moving in the what guides. So these are what guides. So where to flexible rapier is used for the what, for more width of the fabric more than 60 inch, and to guide the tape we require these guide teeths. So this is not required for rigid rapier. Already rigid rapier itself the rod is there, that's why the guidance is not required on the what, and also the construction of frame or drive is stronger in the rigid rapier. So in the flexible shear, ribbed guides lie between the warp ends when the shade is open. When the shade is open and when the sleigh is at the back center to insert the weft, the guides lies in the what warps. The guide passes under the cloth well when the sleigh approaches its most forward position. After inserting the weft, when we are bit-upping the reed, the guide goes below the fail of the cloth. Below the fail of the cloth. So in the next figure we will see that. Close but contactless. High precision positioning of rapier head and rapier close to the reed results in clean shade separation, even with clinging warp ends and a small shade opening angle. So here what happens? The rapier and rapier head are adjusted such that there is hardly 1 mm of gap between your reed and rapier tip. So less is the gap, good opening of shade is there, and less clinging of warp ends will be there if EPI is more and when the shade height is less. So this is what benefit in the what flexible rapier. But in the rigid rapier what happens? The distance between reed and rod is more and more opening of the shade is required here. Shade height required for rigid rapier is more than the flexible rapier. That's why the rigid rapier we cannot increase the speed of the machine. In the flexible rapier as the shade height is less, so we can increase the what speed of the machine. How to increase the speed of the machine means what? If shade height is less stress on the warp will be there. If shade height is more opening we have to more opening will be there, and more the stress on the warp will be there, and we are stretching the warp above its elastic limit. It goes in the plastic limit and your breakages of the ends is there. So always in the rigid rapier here more number of end breaks as compared to flexible rapier when we increase the speed, because shade height in rigid rapier is more than flexible rapier. So here we can see these are what guides: left hand rapier, right hand rapier. So rapier heads design is also different here. So we can see here when the reed is at the backward most position, the shade is open here, and here is the sleeve. On the sleeve we are having ribbed guides like projectile, and here the rapier is going, flexible tape is going from one side to other side. So guide, so here shade opening and closing will be there. The guide, whatever the guides are there like projectile guides, the abrasion of guides with the warp will be there here. Now when the beat up takes place, this guide, the sleigh goes below the fail of the cloth, and the reed goes, whatever the guide is there, it goes below the fail of the cloth. So this is what fail of the cloth position, and this is what backside position. So flexible rapiers here, what are the advantages? So in the rigid rapier we have seen that more space is required, double the width of the fabric. If 60-inch fabric is there, 30-inch on left hand side space is required, and on the right hand side 30-inch. Here no more space is required, less space, floor space requirement, spatially productivities are also higher. So as flexible tape is inserted, the speed, weft insertion speed is more than the what rigid rapier, and the speed of the machine is high, and that's why the production of the fabric is also high in the flexible rapier. Flexible rapier band are owned. So flexible rapier band, it is what flexible. They are owned on the wheels. Winding of the band on the wheels and unwinding is taking place. As wheel moves clockwise, winding of band takes place. As wheel moves anti-clockwise, your band is released, the rapier band goes in the what shade. So this is what winding on the what wheels or placed in semicircular channels when they are withdrawn outside the shade, and the result is what, due to this less floor space required, the working width, and as it is the tape is flexible, we can go up to what 5 meter. So hardly in the rigid rapier we can go up to 2 meter, but here we can see we can go up to what 5 meters. So this is what advantage of what flexible rapiers. So what is the disadvantage advantages here? What is the main disadvantages here? The warp thread should not be damaged by the ribbed guides. So on the slave we are having guides to guide the what rapier, flexible rapier. So these guides, when the warp is opening and closing, when the shade is opening and closing, it is rubbing the guides, and due to the rubbing what happens, your warp threads get damaged, abrated. So dyeing quality will not be good of the warp threads, the look of the fabric changes. Next, guiding system may lead to the end breakage due to the knot failure. So as this end is rubbing to the guides on the sleigh, due to rubbing and abrasion, the end breaks may be there due to the knot failure. Failure of knot is there. If the knot has came in the warping sizing, this knot will be what? Failure. At the knot, the end break may takes place. Again, here what happens? Using fancy yarns in warp direction is almost impossible. So if you are using fancy yarns in the warp, the rubbing of fancy yarn with the guides will be there. And due to rubbing again your fancy yarn breaks, so warp breakages increases. So this is what main disadvantages. Up to 2005 all the rapiers are what? Guided rapiers. Guided rapiers, guided flexible rapiers. After that the change was there and the concept claimed free flight flexible rapier. So in this what we have done, the width of the rapier tape we have increased. Due to increase in the width, the rigidity in the tape came and support came. That's why we do not require here guides. So guides were eliminated. As the guides are eliminated, above all these disadvantages are removed. So by eliminating guides, there is the advantage of reducing end breakage rate due to knot failure, and the viewing of fancy yarn becomes much easier because the obstruction are removed from the warp shade. So we have removed the guides. So this is again we can see there is a west moment, vested moment is there. Again we have seen in the rigid rapier, that is here also flexible rapier west of moment is there. Means what's here? Giver takes the weft from the picking side, it comes to the receiving, it comes to the center of the machine, and from the up to center the gripper, left gripper is what? Loaded, and when the exchange of weft is there to the giver, the taker goes empty, so it is going empty. So this is what moment is wasted. Same here, moment is wasted in the what? Taker. So taker is coming from the right hand side, so it exchange the weft in the center, and so while coming it comes empty, and while going it goes loaded. So this moment is wasted. This is what main disadvantage in the flexible rapier. So this is what complete cycle of the flexible rapier tape. So this is what left hand rapier wheel, right hand rapier wheel, sorry here it is reverse. This is what left hand rapier wheel, and this is what right hand rapier wheel. So this wheel is in the housing, here also housing will be there, and drive will be there here also drive will be there. So see here what happens. So here the cone is there, accumulator is there, tensioner is there. So what happens? Selector, it is selector. So this weft selector is down. So this weft is down means when the rapier moves, the rapier grips this weft by the rapier head, and rapier takes the, and here the reed is at the back center, and this takes the weft up to the what? Center point. So we can see here the weft comes up to the center point. Meanwhile here what happens? This rapier, right hand rapier, so here rapier, flexible rapier tape is there. So here it is fixed by the nut, this position, and at the next end here gripper is there or rapier head. So this is giver, and this is what? Taker rapier. So this is what unwinding means what? The tape is unwounded and the tape goes inside up to the center. So here what happens? It exchanges the weft. तो left hand rapier gives weft to the what? Right hand rapier. Exchange is a giver gives to the taker. Now what happens? Unwinding of the wheel will be there and the rapier goes back. So here the rapier goes back and completely the weft is what? Inserted. Now reed commences forward for the beat up. So as beat up is taking place, here we can see the cutter is there. Left hand cutter and right hand cutter. It cuts the weft and here the beat up will be there. So these are what selector, weft selector. Two selectors are there. One weft selector is down. So both the rapiers are out in the housing. So this is what left hand housing, right hand housing here. And the beat up takes place. Again the cycle is repeated, the reed goes backside, the weft is gripped by the left hand rapier, it comes to the center, then right hand rapier, it takes goes to up to the center and exchange of weft. So right hand rapier takes the weft and this goes empty. Left hand rapier goes here, this is what going empty. So like this is what cycle of the flexible tip and this is what tip to tip transfer it is called as. So we can see here the rigid. So now the concept is clear now. What the things we are completed here in the classification of rapier. The rapier may be of single-sided rapier. The rapier may be of double-sided rapier. In the double-sided rapier, we have seen uh, flexible rapier and rigid rapier. So I think now the things are clear here. So once again see the figure carefully. So your ideas will be clear. Say slave backside position, slave front side position, then rapier selection, web selection. This is what picking side, this is what receiving side. These are the flywheels. Left hand drive is different, right hand drive is different. From the main motor only the drive is going for left hand and right hand. So in the flexible, we have discussed that in earlier we were having the guides on the sleigh to guide the rapier. That's why more number of breakages were there in the warp direction and fancy yarn could not be used. So now in earlier the tape width is increased. That's why the guides have been removed on the sleigh and warp breakage rate is reduced and we can use fancy yarns here. So this is what advantages of what flexible rapier weaving. So flexible rapiers available in the market is what from the Smith good machine. Rigid rapier, the machine only available is what Dornier rapier from Italy, Smith from Italy. So Smith is what well established company in the what flexible rapier running with the speed of from second hand machines run at 250 rpm, new machines run at 450 rpm and whatever the latest advanced machines are there they are running with the what 600 rpm. So we can see here from 1990 to 2020 the advancement in the electronics is going on and as the advancement in electronics is going on less number of moving parts are used. So 1990 machine more mechanical machine, the speed is less, for the driving more mechanical elements and these all the mechanical elements or driving force or driving motors they have been replaced with what advanced thing and less number of mechanical parts we are used towards 2020 and the speed of machine has been increased. So this is what rapier. In the next lecture other classification we will see that is what devas and gabler. Either we have to purchase devas type of rapier weaving machine or gabler type of rapier weaving machine. So in the next lecture we'll continue with the concept. So once again see the figure. Again much more figures are there, we can concentrate and we can see here. So this is what rigid rapier. So this is again flexible rapier I am showing, cutter, clockwise movement, anti-clockwise. This figure is clear. So this was single rapier. So these are the concept we have covered.